Hello. Okay, so today we'll be solving a Codeforces Div 3 problem which came in today's contest. So let's start by understanding the question itself. So the question was problem D. So in this question you would be given an array n of n integers and q queries. Now each query is represented by two integers l and r, right? So and like these lnr denote the range in the particular array, and your task is to find for each query you have to find any two indexes such that these conditions are met. So what are these conditions? These conditions say that you have to select two indexes such that the value which are present in that range is not equal to which is it is not equal. So let's take an example. So if the array element is like 1 5 3 2 2 5 8, right? And let's assume that you are given a range from l equals to 1. Like if I name this as 1 base indexing, so it would be this is index, right? This is index, so this will be 1 2 3 4 5 6 and 7. So for now if I now for there would be q queries, right? So in the first query if I give you range, let's say 2 to 5, right? So in this you have to print any two numbers, any two indexes as that value present at both the numbers are not equal. So I can even print here as like 2 and 3 because value is different. Okay, a valid answer can be also 3 and 2, right? A valid answer can also be 3 and 2, but a valid answer cannot be 4 and 5 because these two values are same. So I hope you got the question. So just let me take one more query. So for example, if the second query was let's say 4 to 5. So in this 4 to 5, uh, since no numbers are equal, you have to print two indexes as -1, denoting that no indexes were present, right? So just this was the question. So constraints were 2 into 10 to power 5. Uh, if you assume that value of q over all test cases, so maybe you have to now design a solution which passes in let's say order of n in like q queries are there already. So maybe n log n or n into q if you just neglect the queries part. So n log n or n log n into q, that part. So you have to find an algorithm or you have to denote a way, find a way such that you can solve this. Now let's discuss an approach like how would you try to solve that, right? So now since you know that the brute force solution would not pass, so what do I mean by brute force solution is that if you apply brute force, then like for each query q you have to traverse. So for example, if let's assume that this is the array and you have been given this range, right, l to r. So for q queries you can't traverse whole from the range l to r and check whether two elements are distinct or not, right? So you have to optimize this. So let's start like what can we think. So if you just look upon the question once again. So it was told that you have to find just two integers which are not equal. Can we modify this and say that if I'm telling that if this is an array, right, if this is an array range and I tell that you have to find two numbers such that from any two numbers in this range are not equal, then if it is so, then print the indexes, otherwise print -1, right? If it is not present, if it was present, print two indexes. So can I modify this and tell that -1 and -1, like this would be that case only when all the numbers in this range are equal, right? So one thing is clear, that if you anyhow like figure out that all numbers in this range are equal, right? If these all numbers are equal in this range, you directly print -1. Otherwise you can think of like how to find two numbers, correct? So first part is least equal part leads us to the thinking of that approach, that like how can we in the given particular range, right, if this is the particular range l to r, how can we for q queries how can we find that whether the numbers in this range is equal or not? So you have to just think. This was the first approach, first thought process. So finding out, like finding whether all numbers were, whether like not summation, uh, whether all numbers in that range were equal or not, right? So just let me erase this, but yes. So whether AI for all I, for AI for all I from L to R, that is same or not, right? That is same. So if I am able to figure this out, I am clearly able to differentiate that my answer exists or it does not exist, right? So I hope this till this much it is clear. Now, how to find whether that range contains equal numbers or not. So let me just take an example. So let's assume that the array elements were 1, 2, 3, 4, and then 4, 4, 4, 4, 4, 5, 6, 7, right? And now I tell you that you have to find that whether in this range array elements are equal or not. So how will you do that? So if you just see, or just let me modify the example a little bit, right? Just let me remove this for now. It will be much more clear to understand. So if I tell you to find out whether all the numbers would be in this range would be equal or not, can I, like, because since I have, like, what values do I have? I have the outer boundaries, right? So if I say that 4 occurs that many number of times which is present in the length, right? So what do I mean by this is that if I am able to figure out how many times is 4 occurring in this length by just having some pre-computed values at this LNR, then it would be, my work would be easy, right? So for this, I construct a length array, right? A prefix length, or maybe you can denote anything. So I just name it as prefix length array. So if what is this array? It denotes, like, if I'm standing at the ith position, right? The number it is denoting that that many number of numbers are contiguously present in that array, right? So let me just first construct an array, then you, I think you will be able to understand, like, why, what I'm trying to say. So if I'm at this, so my contiguous number is 1, right? Because 1 is present one time. Here also, since 2 was different than 1, I would again tell it as 1. Now I came to 3. The length also would be here as 1, right? Now I came to 4. Here also the length would be 1, because, like, 4 is starting from here only, at contiguous length is 1. Now when I come to this point, I know that 4 has occurred, like it was just before it. So I will increment the length 1 and 2. Similarly, if I'm here, then I will increment the length. And for this 4, I will increment the length, right? Now when I came at this position, since 5 was different than 4, I would reset it to 1. Again, I would do this for this element, and for this element, I would again do that. Now can you observe a pattern? If I tell you to, if I query from this L to R, can you, in order of 1, right, can you in order of 1 tell me, like, whether all elements are present or equal or not? So if you just carefully look this, what can I do? I will say that the prefix, if I denote L and R, so if I tell that uh, prefix at R minus prefix at L, right, minus plus 1. So what is this? This denotes the length in the prefix contiguous array, and I will check whether that is equal to the length of the array, sub array, right? R minus L plus 1. So if these is equal, then I am sure that, since, because this denotes that how many number are contiguously present in that as sub array, and this denotes the length of the sub array. So if I'm telling for this sub array, these many elements are there, right? For this length R minus L plus 1, if these many elements are there, then I'm sure that all the elements are same. So just let me take a different example. So if I tell, like, if instead of this 4 4 4 4, if it was 4 4 5 4, right, and the remaining elements were same 5 6 7, and here 1 2 3, then what would the prefix array, prefix length look like? So it would be 1 1 1, 1 2 1, because it was resetted to 1 again, 1 1 1 1. So if you just see, right, because it was not contiguous, you will not get the, by subtracting less 1 minus 1, plus 1, right? So you would not get the length of the subarray. I hope you get this point. So if by subtracting the length, if you're getting the length of the subarray itself, then you're sure that all the numbers are equal. So this clears out that whether you are able to just tell that just I mean whether you are able to directly tell whether minus 1 whether you are able to even get answer or not, right? So if you are able to get this part, that this condition is equal to this, then you are sure that two numbers exist. Now you have to figure out a way in which you will print that. But if that is not case, you can just print minus 1 and move on, right? So let's think how would you try to figure out two indexes. So uh, let's now think that how so you, now you are clear that in this range two numbers are there such that which are different, and you have to just figure out like which number is different. So just now let us think on the prefix array which we had constructed before, that how can we manipulate and use that, right? So imagine that our this range, I'm just talking about this range. So if the numbers are like 4 4 4 4 5 uh, 5 5 4 4, right? And some extra numbers were here also and in the before here. So this was the range I'm talking about. So if you just the first thing was that if you just do prefix r minus prefix l, then you can just print like if you just print minus 1 and minus 1, right? Then it would be not worth it, right? It would be, yeah. So just let me be one more time clear. So if you, so the first thing was that if this is the condition, then you just print minus 1 and minus 1 because you are sure that it means all numbers are same, right? All numbers are same. All numbers here are same, right? So just forgive me for bad handwriting. Yeah, all numbers are same. So now if you now do prefix r minus prefix l, so if when you construct the prefix array, right? Okay, just forget this from now, just concentrate on this part. So the prefix length would be 1 2 3 4, then again it would be resetted 1 2, then 1 2, right? Then now let's first calculate prefix r minus prefix l minus 1, like whether, like let's check this condition. Since 2 minus 1 plus 1, right? Because this was 2 and this was 1, if this is ln r, that is not equal to the length, right? Length was I guess 1 2 3 4 5 6 7 8, right? This is not equal to it, so you are sure that there exist two numbers. So since just now, so you have to figure out how would you find that two numbers. So if you just look this part carefully, so this is telling that you have some contiguous numbers before it. So the 2 tells that there are two numbers before it which are continuous. 3 tells there are three numbers continuous before it. So as soon as you find a number which disrupts that part, so what do we mean by this is, since uh, you found that this is an increasing order of nature. If you just look at this part 1 2 3 4, and here the breaking point was there. So I hope you are getting the feel of binaries, applying binary search on this part. Why? Because imagine that you are applying binary search in this lnr. Now since you know that like if you are standing at this point and some numbers are increasing same, so it would be like 1 2 3 4 5 6, right? And here for example a new number came, so again it disrupted and it became 1 2 3. If these numbers are same, then again 1 2, something like this. Now if I tell you to apply binary search, so if I tell you to this is l and this is r, and let's say this is the midpoint, right? So if I tell that you have to find this disrupted point, why, like this break point, because if you find this break point, then you got two numbers, right? Because this ensured that a new number came and this ensured like that it was a forming continuous forming array. So if this is the break point, let me name it as break, right? If it is denoted by p, and if my l is denoted by this, then if I print l and p indexes, then it would be my answer, right? Because uh, at p I ensured that a new breakpoint was there. So if I just apply a binary search, then I would be able to get this breakpoint. So how would I apply binary search? It would be just a simple thing. If my mid value it is in this range, right? Then I would try to maximize the mid lower point. Otherwise, if it is this range, I would minimize the lower point. So just let me now show you my code. Then it will be much more clearer. So now let's look up to the solution. So first, as you know, we had to construct this prefix length, like this prefix length array. So for this, what did I do? I first took the input and then I constructed the prefix of one base indexing. So I also ensured I am taking the array as one base indexing. So if my current element is equal to previous element, I would increment the prefix length by one. Otherwise, I would reset it to one, like as you saw in here, like in this example. Like if new element was there, if new element was found, like 3 and 4, it was resetted to one. Otherwise, if it was same to previous element, you incremented it by one. Now let's move to the second part, that for Q queries you have to perform this operation. So as I told you, we first you have to check this matching condition. If that is so, then you have just print minus one. Otherwise, you apply binary search on low and high range. And while applying binary search, you just need to check. So just let me again revise you what how was I applying. So if you know that if this is my point L, and I was applying binary search, so this is now increasing, right? Because it was all continuous point. So for let's say I calculate a midpoint. So if it is the midpoint, how do I ensure that it's whether it belongs to right part or left part? So if it was in the left part, then the numbers here and the difference between the prefix, right, it would be same, right? So I did by calculating this. If that is a condition, I increment my low pointer. Otherwise, I know that I have to find this breakpoint, so I maximize this and shift the high pointer. So you can just go through it once again. I hope it will be then clear more. And at last I print the L value and the answer. So L is basically this point and answer is basically my highest point, like after just the break point after I got this. So I hope you got my explanation. Thank you, and do subscribe and like if you find my videos helpful. Thank you.